Hello there, my name is Julio, and these are my students! Woo! So let's start. Come on. Okay, yeah. So in this episode we're going to see... So one of the applications of the definite integrals is to know the area of two graphs. So let's put an easy example. So now let's graph both of the equations. So here we have the graph for this one. As we can see, it's negative, and here this one is for this one. As we can see, it's positive. But we only want to know this area. But first of all, we need to know the roots. So what we're going to do first is to equalize both of the equations. And now, something that we can do is to factorize. So this is how we factorize. And as we can see in this equation, the first root is 0 and obviously 2. So we want to find the area between the 0 and the 2. So now, in order to integrate, we need to rest the upper minus the lower. In this case, the upper one is this one, and the lower is this one. Well, we already have our roots that are 0 and 2. So now we're going to pass to the rest. So we have the upper, that is for x minus x squared minus x squared. So we're writing 2 here and 0 here because the graph is in the positive part. And now we integrate. Okay, so we already have this equation integrated. And now what we're going to do is to substitute these values into the x. So it would be, and that's equal to, okay, so this was the result, and now we go here, and this area here is 8/3. So this was a really easy example of the definite integrals. Hope you understood, and I say goodbye. So now my student Luisillo is going to explain some other things.
Okay, so as a part of the definite integrals, we have distance and displacement. Well, here is a little problem. The problem says that we have to sketch the graph and find the displacement and the distance of the particle. Okay, so here is the graph of the function 9 minus t to the square. Okay, so we are using the interval from 0 to 4. Okay, and let's mark the limits. Okay, now so let's find the displacement. Okay, so let's make the integral for this function. Okay, so this will be the displacement of the particle between 0 and 4. Okay, but what is the difference between distance and displacement? Okay, the displacement takes into consideration the signs, but the distance doesn't.
So to find the total distance, we need to split the integrals, and we have to put in the first one the limits from 0 to 3 because this part is all positive, and in the second integral we have to switch the limits, the 4 here and the 3 here, because this part is negative. So we can also put a sign here and the limits 4 and 3 here, but it's easier this way. So now we already have the integrals, and we just need to substitute the values. Here the 3 and here the 0, and we rest them. It is 18. Then we do the same here, the 3 here and 4 here. The result is this one, and we just sum both results, and we have 64 over 3, which is the total distance.
Teacher, you didn't explain how to find the roots.
Okay, so to find the roots, we have to factorize the function, which is... So this is another way in which you can use the definite integrals.
Well, the definite integrals also work to solve problems with the rate of change. For example, if we are given a function that means the rate of growth of the fish population, like this one, if we make a definite integral, we will find the rate of change in the population of fish between the given limits, that means the weeks. In this case will be week 1 and week 4. So first we are going to make the integral of the function, and we are going to set the limits from 1 to 4. And to find this result, this is the result of the integral, we need to substitute this part because we cannot make the integral just like that. So u will be 0.2t plus 0.4, and our du will be 0.2. We are going to take the constant outside the integral. So once we have resolved the integral, it would look like this. So the final result would be 100 thirds. Then we are going to do the next part of the integral, that is 1 dt. That's very simple. It's just 1t. So once we have resolved the integral, we are going to make a substitution to find the definite value. So in this case, we first are going to substitute the 4 in the 4 dt's. The result of that substitution in this problem, in this function, is 22.13 minus 4, and the result from the substitution from 1 is 12.14 minus 1. So the final result is 46.96, but it can be half a fish or 1/4 of a fish, so the rate of change will only be 46. And we can conclude that the change in the population from week 1 to week 4 was 46 fish. So that's another way to use the definite integrals, and that's all.
Well, but after all we have seen, you may wonder, why are definite integrals important in your day-to-day life? Well, we have this example, for example, the fish growth rate, which is if you happen to have a fish farm, you can use it to calculate how many fishes you will have in a week, 4 weeks, in a determinate amount of time. Another example was the particle, for example, in physics. Engineers at the Large Hadron Collider can use this formula, the definite integrals, to calculate how much a particle travels, the distance and the displacement. But last, we may not use it in our real life, in our work, in our family, but everything we use, from computers, maybe even to our food, to our transportation, airplanes or cars, use this type of functions, the definite integrals. That's why they are important, because they make the system work. Thank you.
So that was all, folks.
See you
next
next time.
time.